Hey, who out there is ready to geek out with good old Jimmy Ray? Get on in here and join me in Networking 101. How many folks out there ever wanted to be a casting agent? You know what? If you run an Ethernet network, you kind of are, right? You kind of work with unicast, multicast, and broadcast. See what I did there? All right. You know, when we're looking at designing this, looking at our networks and we're passing traffic, there's a whole bunch of stuff out there, but in the end, it all boils down to one of three types of traffic out there. First off, you have what we call a unicast, right? Unicast, these are the most simple that's out there. They are A to B type of communication. If I want to send a message to Rob, then I just communicate, I send it directly to him. I don't let anybody else see it. We pass it through. A lot of times we can encrypt it, whatever. But unicast traffic is direct, one-to-one, A to B type of communication. Our next traffic, which gets a black eye quite a bit, is what we call broadcast traffic. Now, broadcast traffic is very useful on the Ethernet because what it does is that it allows me to send a bunch of information or information out to multiple devices at once. Now, why does it get a black eye on the network? Well, simply because people will say that this will flood the network out, and by rule, by regulation, if your device receives a broadcast packet, it absolutely must receive it. It must pull it in and process it from start to finish and find out what it is that applies to that, right? And there's quite a bit of broadcast information or packets out there. So a lot of folks really do not like the idea of all this broadcast information being out of the network. But you have to look at why we did this. Kind of goes back to the old Ether days, right? So back in the day, actually, if you even look at the Ethernet symbol, you'll see that you've got this, you know, kind of odd-looking character in there. And you're like, you know, what the heck is this thing? Back in the day, what we did is that the Ethernet was actually based upon, you had this one single main line that you installed in a building. And man, be glad those days are over. It was thick, it was heavy, it was just a real pain in the tail to actually plug this thing in. And you'd snake it through every level. It was one cable that actually connected out. And then your devices, your machines, would hang off of it, right? They would tap. We called these vampire taps. That was before vampires kind of sucked with the whole Twilight thing and stuff, and were kind of cool. But they would hang off this device, and everybody would communicate, or they would ring out on this one line. And so that's why the symbol still carries over. A little traditional action right there. So to find these devices, remember one line here, you had to actually send out a broadcast message and just say, hey, does anybody know where this information is, or whatever the case may be, so that devices on this line could pull it in and could kind of process it, and they could figure it out. One cable, one way of communication stuff. So that is kind of carried over even in the star type of networks that we all have today, where everything is kind of connected out. It may seem like broadcasts are kind of a thing of the past, but it's a carryover. They're going to be in networking for as long as we can possibly see. They're actually in IPv6 as well. You know, NDP, anycasting, all that type of stuff. So you'll actually see a lot of those carry over because it's just the quickest way. It's a very quick, efficient way to get that out. You can control that. Every vendor has their own levels of broadcast control where you can clip that information down. I recommend doing it. Do it in the lab first, though, because you want to test it and make sure that you're not, you know, knocking down requests, because it's a great way of denial of service, right? If I want to stop you from receiving information, then all I got to do is start sending out broadcast frames, and everybody's going to start processing. And if you ever want to see this in action, some devices out there will have spanning tree turned off by default. And if somebody, and trust me, sometime in your career you'll probably end up doing this, and hopefully not more than once. But if you're like me, chances are you probably will do it more than probably 3 or 4 times. But Ethernet can only communicate in this type of direction. If you close the loop on it, then it starts broadcasting back on itself, and it gets bigger and bigger and bigger and bigger and starts spooling up. And so then what you have is all these machines hanging off of it. Now they've got to start spooling that information as well, and the network performance will just crash, man. It'll get really, really bad. So, you know, you're going to want to have some control to kind of clip this, and you don't want all that broadcast storming happen on your network. Now, The other one that we see on the network all the time, or that you'll see with a lot, is multicast. And multicast is a little more complex in what we do with the network, because in its most basic form, what you're doing is that you're having a device, and typically it's a server, is going to send out a request, and that request is going to be a very specific IP address, right? And you can tell it. It'll be like 239. That'll be the start. It'll be your first octet. It'll range from 239 to 244. It'll say, okay, well, these are specific addresses, what they even call Class D addresses. So if you ever see that on an exam, you'll know. A Class D address is a multicast address. And what you'll see is that this device will send out, and it'll say, I want to send out information for anybody who's interested in listening to this group. So if you're going to go to, let's say, techwisetv.com, you subscribe to that channel, we start multicasting this information out so you don't have a flood of video, which video is very, intensive on a network. We don't want that to happen. We don't want everybody to have to process this. We want people to selectively join that group and subscribe to it. That's what multicasting does, is that it allows you to have basically somebody that's transmitting this information. It'll be received by the switch. The switch itself has the intelligence to only send that traffic down to the ports that are actually listening to that information, that want to. And how do they listen to that information? They do what's called a join. They do an IGMP type of join message, and they'll say, I'm going to draw on that screen someday. They're going to send up a request and says, hey, I want to watch TechWise TV, and I want to join the group that's actually broadcasting that information on our network. And so the switch will receive this. It'll put it in its multicast tables, and it knows when it receives that address. So we'll say it's a 239, and it's assigned to the techwisetv.com type of subscriber group. Then it will only forward it down to the people who want to listen to it. And it works pretty darn cool. There's also ways to design equipment switches to actually do what's called leave, because what you don't want is you don't want this group hanging open. So if, let's say that somebody's listening to this, and then they have to shut it down because they have to leave, or they're kind of getting tired of listening to me rattle on about something. So they're like, well, I don't want to hear this anymore. I want to go and do some other, work, real work. We don't want to keep flooding them with requests just because they turn it off, they shut down their client. That client's going to send a leave, and that switch is then going to remove it from its table, and it's going to say, oh, okay, do not send any more multicast messages to port 20 because they're done listening with that. And how quickly you can do that really determines how efficient that type of switch is. Multicasting, man, it can get very, very difficult. Out of all these concepts to learn, Unicast, multicast is by far one of the most difficult out there to understand and to really dig. If you really invest some time into it, man, it's really, really cool because you can route it since it is assigned a Class D address. You can actually route that stuff across. A lot of routing protocols use it, especially OSPF. It uses multicast to find other routers that are listening to it, that type of stuff. And it's really, really cool. And there's different ways to route it and send it across and stuff. But if you're having a hard time understanding it, take a step back, go back to the basics, and try and figure out, what is it that we're trying to send to? Who wants to hear it? How do they want to receive it? And how can I do it the most efficient way possible? Do I have a router in between, yes or no? And then start solving the problem from there on out, and you'll be ready to go.